Hello everyone, I am Shamanth, CSAT faculty at Insights IAS. I welcome you once again for the question of the day series. This is the last video's bouncer, that is the homework question for you guys. Okay, I hope you have solved this one. See, look here now. This is a question from the permutation. The question says how many 4-digit numbers are possible using the digits 1, 2, 5, 6, 7, 8, 9 as well as 0. Okay, in the last video also I have explained how to take 4-digit, make 4 positions like this. Okay, make 4 positions like this for 4 digits. Now, for this position, okay, always start from the left hand side. For this position, how many choices will be there? For this position, either you can put 1 or else 2 or else 5 or else 6, 7, 8, 9, 0. But here, the question he is saying 4-digit numbers, that's it. Okay, he has not mentioned this has to be repetition or else no repetition. Since no condition has been given, even though it's repetition, all the numbers has to be counted. If no condition is given, what are all possible numbers? Okay, even though the numbers digits are repeating in a number, that also has to be counted here. Now, for this position, okay, if I put 0 here and if I put whatever the numbers, is it become a 4-digit number? No. If I start from 0, this becomes a 3-digit number. Hence, you cannot use 0 here. Other than 0, any other digit you can use here, means either 1 or 2, 5, 6, 7, 8, 9. So, how many digits are there? 1, 2, 3, 4, 5, 6, 7, 8. But out of 1, the remaining are 7. Okay, you cannot use 0. This is 7 choices you are having. Let's say you have written 1 here. Can I use the same 1? Okay, since there is no condition of repetition or non-repetition, repetition is allowed only. For this position, along with 0, whatever you have used here, again you can use it. So, 8 other choices. Similarly, here also 8 choices. Okay, similarly, here also 8 choices. Okay, in the previous video also I have explained, this is AND case. AND means multiplication. So, which is nothing but 8 cube into 7, which is 3584. And this is the today's question. The question says find the smallest number. Smallest can also be given as here minimum, least number, which is completely divisible by 15, 30, 36, 40, 48 by leaving 7 remainder in each case. Okay, remainder has to be 7 in each case. Now look here. Okay, this is a question under concept of LCM. You know your school method of finding the LCM. Okay, for example, how to find the LCM of 4 and 8. See, you start from the smallest dividing number. Okay, this is 2 times, this is 4 times. Again, you take 2, 1 time, 2 times. So, this is 2 again. Okay, you guys are familiar with this one. I will show you one more now. Now, let us take 8 and 20. What is the LCM of 8 and 20? This 8 can be written in the form of 2 into 2 into 2, where these 2 are called prime factors. Factors means divisors, and all of these are prime numbers, hence prime factor. Similarly, this 20 can also be written as 2 into 2, which are prime number. Anyway, this can be written as 4 into 5, but 4 is not a prime number. Hence, I am splitting this 4 into 2 into 2 into 5. Okay. Remember, always LCM has to be greater than or equal to the largest or the greatest number. Whatever the greatest number, okay, whatever the largest number here is there, it has to be equal to that largest number or else greater than that largest number. And similarly, HCF has to be always less than or equal to the smallest number. Okay, keep this in mind. Now, these are the prime factors of 8, these are the prime factors of 20. Now, take the largest number, okay, largest number, and compare this largest number's factors with the smallest number factors. When I compare these numbers with this number, we have 2 and 2 and 5 here. Okay, we have 2, 2, 5. But when I compare here, this has 3 2s. Okay, means one extra 2 is there. Whatever extra this is having, take here and multiply here. If I multiply, that means 20 into 2 I will be multiplying, which itself becomes LCM. Okay, which itself becomes LCM here. Now, okay, if I take the LCM in a similar way here, see, 48 can be splitted as, see, this is 12 into 4. Okay, 12 into 4, where 12 can also be split as, see, this is 4 into 3, again this one as, let us keep this as 4. Inside this 4 we have 2 2s, inside this 4 we have 2 2s. Similarly, this 40 can be split into 4 into 2 into 5. When I compare these factors with this one, okay, here see we have 4, here also we have 4. Here we have 2, in this 4 we have 2. We do not have 5 here, that is why I am taking this 5 and multiplying here, okay. This 5 I have taken here, okay. Now, here we have 2 6s, means see look here, when I take this one, see this is we are having 4 here, okay. There is one more 4 here, isn't it? In this 4 we have a 2, okay, which if I multiply with 3 I will get 6, but here we have 2, we do not have a 3 here. 2 6s means 6 and 6 can be written in the form of 2 3 and 2 3. Here 2 3 is there, 2 here, 3 here, okay. We have a 2, we do not have a 3, hence I am taking 3 here, okay. Now 30 in which we have 6 and 5, see we have a 6 here, 2 inside this one, 3 here, 6 it becomes into 5, it is 30. Similarly 15, we have a 5 and a 3, we already have taken, okay. So what have taken? 5 and a 3. If I multiply 5 and a 3 with 48, okay, which is nothing but 48 into 15, 720 it becomes, okay. This is how you have to learn through the concepts, guys, okay. 720 is the LCM, okay, but this is the smallest number. LCM means the smallest number which is completely divisible by all these given numbers, okay. Is asking there is one such number which when I divide by 15, 30, 36, 40 and 48, it has to be completely divisible. One such number is 720. This is the first number, smallest one which is completely divisible by all these numbers. But the question says the remainder has to be 7, means it has to be 7 more than this particular completely dividing number. So, what must be the answer? LCM plus the remainder, which is nothing but 727. Using the similar approach, try to solve this question. This is the bouncer of the day question, and try to put the answer in the comment section. Thank you. We will see you in the next video.